Welcome once again to Esomnof Chidebube online mathematics class. Today we are going to deal with all the problems in circle theorem that has come out in WAEC from time immemorial. We'll be dealing with this on weekly basis. In less than 2 months, we may finish all the problems that have come out in WAEC under circle theorem. Kindly listen, share, and subscribe to my channel. Okay, like I said, we'll be picking them one after the other, all the problems in circle theory that have come out in WAEC from time immemorial. Okay, so look at this shape. A triangle is inscribed in a circle, and we are asked to get the values of x and y. Remember, to be more okay in this circle theorem, to be efficient in tackling problems involving circle theory, you should first of all go and learn all the theorems involving circles. Now, looking at this number here, 43 degrees, there is what we call vertically opposite angle. Okay, so if here is 43 degrees, automatically the angle here is vertically opposite to this 43 degrees. So if here is 43, I can write that here is also 43 degrees because they are vertically opposite angles. Now we have succeeded in finding out that the angle here is 43 degrees. What else do we do? Because in a triangle you must have up to 3 angles there, but here I'm having just one. Had it been I know this or this, it would be very easy for me to get the remaining angles. Okay, but there is one thing students always forget when it comes to this circle theorem. They easily forget the isosceles triangle. Okay, now this smaller triangle here, you find out that the this side is running from the circumference to the center, and this side is running from the circumference to the center. So this line and this line are equal because they are all radius. Remember, a radius is a line running from the center of a circle to any part of the circumference. So if that is so, it means that this is isosceles triangle. Therefore, y is also equal to 43 degrees. Reason, base angles of isosceles triangle. That's the value of y because the base angle of isosceles triangle. Now it is not easy to get the angle at O since I have known 2 angles. So angle at O, that's angle at the center, will now be 180 degrees minus the sum of 43 degrees and the 43 degrees, because this is a triangle and the sum of angles in a triangle is 180 degrees. So angle at center now will be 180 degrees minus, when I sum 43 degrees and 43 degrees, I will get 86 degrees. Okay, now removing 86 degrees from 180 degrees gives me 94 degrees. So angle at center is now 94 degrees. But there is another theorem in circle which is telling us that angle at center is twice angle at circumference. Okay, so x will now be 94 degrees over 2, which is around 47 degrees. Reason, angle at center is twice angle at circumference. Okay, that's the reason we are dividing 94 degrees by 2, because angle at center doubles that at the circumference. Okay, we are going to take another question to this effect. All right. Okay, problem 2 again. All these problems we are solving are from WAEC past questions. So you are given this diagram and you are asked to find the reflex angle POQ, POR, POR. So we are looking for angle POR now. But we are only given one angle, 80 degrees. So, but you know that this line is touching the circumference of a circle exactly at one point, and this line also is touching the circumference of a circle exactly at a point. Now, any line touching the circumference of a circle exactly at a point is known as a tangent to the circle. Okay, and there is a theorem which is telling us that the angle between a tangent and a radius, this is a radius because it is moving from center to circumference. So the angle between a tangent and a radius is 90 degrees. So this angle is 90 degrees. You should know that. Angle between a tangent and a radius is 90 degrees. Also, this is another radius because it is moving from center to circumference. There is another radius. So this angle is also 90 degrees. So let us get this angle here because this shape has 4 sides, 1, 2, 3, and 4. It's having 4 sides, and when a shape has 4 sides, it is a quadrilateral. Hence, the sum of angles of a quadrilateral is 360 degrees. Therefore, angle POR will be 360 degrees minus the sum of 90 degrees and the 90 degrees and 80 degrees. So I'm going to sum 90, 80, 90 and remove from 360 degrees to get the angle here. So I'll have it as 360 degrees minus 90 plus 90 is 180. 180 plus 80 will give us 260 degrees. When I subtract, I will get 100. That is angle POR. But WAEC is tricky. The required angle is not POR because they mentioned we should find the reflex angle POR. Remember, for any angle to be reflex, it must be greater than 180 degrees but less than 360. But this 100 is less than 180, therefore it's not reflex, which means the POR they want is the one here at the back. That's what they want us to get. And this is sum of angles at a point. Therefore, reflex angle POR will now be 360 degrees minus 100 degrees. The reason is sum of angles at a point. Sum of angles at a point. So the required angle will give us 260 degrees. Okay, we'll take another question. Okay, we want to take the third question. You can see this shape. We are told that RP is a diameter. Then we should get angle STR. So this is the angle we need to get. So, but since they told us that RP is a diameter, we need to suspect one thing, which means this now each of the parts up and down here are all semicircle. Okay, then I can cut out something like this at the circumference so that I can have the angle at the circumference of a circle here. But there is a theorem which is telling us that angle in a semicircle is 90 degrees because we are told that RP is a diameter. Hence, angle RSP, and this angle here, is equal to 90 degrees. Reason, angle in a semicircle. Angle in a semicircle is 90 degrees. So I can get the angle here because in the triangle, I have known that here is now 90 degrees. Okay, so it's now easy to get this angle. Hence, angle RPS, this angle here, will be equal to 180 degrees minus 90 degrees plus 24 degrees. Reason, sum of angles of a triangle is 180 degrees. So angle RPS will give us 180 degrees minus 90 plus 24 is 114 degrees. And when I subtract, RPS will give me 56? 66 degrees. Okay, so this angle now is 66 degrees. But this is angle on a straight line, and angle on a straight line is 180 degrees. So if here is 66, it means that this angle will be 180 degrees minus 66 degrees. Hence, the angle here is still 114 degrees. Okay, Do you know that I am free to still extend this line? If I extend this line, I will have that the angle between a tangent, this is a tangent, and a chord is equal to the angle in the alternate segment. There is a theorem that says this. So this is the angle between a chord, this is a chord, and this is a tangent. It is equal to the angle in the alternate segment. So if here is 66, automatically the angle here will also be 66 degrees. And this is now a straight line. The sum of angles in a straight line is 180 degrees. Therefore, to get this angle that is here, I'm going to add 66 and 90 degrees, then remove it from 180 to get the angle that is here. So hence, angle PST will be 180 degrees minus 90 degrees plus 66 degrees, because this is sum of angles on a straight line. Okay, if I add this and remove it from 180, I'll be getting around 24 degrees. Okay, it will give me 24 degrees. So the angle here is 24 degrees. So finally, to get what they want, they said we should get angle STR. Angle STR, which is this angle here. We have now seen that here is a triangle. So I will sum these two angles and remove it from 180 degrees to get the value of angle STR. Therefore, angle STR will be 180 degrees minus 114 degrees plus 24 degrees, raising sum of angles in a triangle. So angle STR will now be 180 degrees minus 114 plus 24 will give us 138 degrees. Okay, now remove 138 from 180, we will be getting around 42 degrees. Okay, so the answer here is 42 degrees. Okay, this is the fourth question. We are given this figure, and the question made mention of the fact that this is the center of the circle, and we are asked to find the value of x. Now, whenever you are given a diameter, or you are told that a point is the center of the circle, please suspect angle in a semicircle, because once you have center, it means half, and half of a circle is a semicircle. So this angle here must be 90 degrees, because the angle in a semicircle is 90 degrees. A circle theorem said that. So I will write that angle NML is 90 degrees, raising angle in a semicircle. So the angle in a semicircle is 90 degrees. And this is just a triangle. So I have to sum all these angles here and equate with 180 degrees. So x minus 5 plus x plus 15 plus 90 degrees is 180 degrees, raising sum of angles in a triangle. Okay, now this is simple algebraic equation. X plus x is giving us 2x, minus 5 plus 15 is just 10, and 10 plus 90 will give us 100, equal to 180 degrees. Now this 100 will cross to the other side, it will change to minus. So 2x is now 180 degrees minus 100 degrees. And 180 minus 100 is just 80 degrees. So I'll divide both sides by 2. So our x is now 40 degrees. So you see how simple this problem is. Let's take another one. Okay, in this video, let us conclude with this last question. So we are asked to find the value of angle UXY. Look at the whole figure here. They say we should get U, X, and Y, which means they are interested in this angle that is here. Okay, so how do we get it? Now, always be sensitive whenever you see some information in a circle. They mark this place and this place, showing that the two lines are equal. Okay, so be suspecting isosceles triangle. because in isosceles triangle, the two sides are equal, and if the two sides are equal, automatically the base angles are equal. There is a theorem in a circle which is telling us that the angle between a chord, this is a chord, and a tangent is equal to the angle in the alternate segment. So if here is 50, here will also be 50 degrees. We call it angle between a chord, this is a chord, and this is a tangent. The angle between a chord and a tangent is equal to the angle in the alternate segment. So if here is 50, here is 50. Therefore, you can write that angle VUX is 50 degrees alternate segment. Okay, so here is 50 degrees. Now, this side and this side are equal in this isosceles triangle. And one property of isosceles triangle is that the base angles are equal. So if here is 50, automatically here is also 50 degrees. So I can say, right, that angle UXV is 50 degrees. U, X, and V, 50. Why? Base angles of isosceles triangle. Base angles of isosceles triangle. Okay? So here is 50, here is 50. It is not easy to get the angle at V. Okay? Because the sum of angles in a triangle is 180 degrees. So angle UVX will be 180 degrees minus sum of this and this. Okay, 50 degrees plus 50 degrees. So angle UVX will give us 180 degrees minus 100. Because when I sum 50 and 50, I'm getting 100. When I subtract, it's giving me 80 degrees. So this angle here is 80 degrees. But we are not looking for this angle. Our target is to get this angle according to the question. They said UXY. Also, this is another chord, and this is a tangent. So angle between a chord and a tangent is equal to the angle in the alternate segment. So if here is 80 degrees, automatically here will also be 80 degrees. Therefore, angle UXY is equal to 80 degrees. Reason: angle between a chord and a tangent is equal to the angle in the alternate segment. So for this section, I'm stopping here now. Expect new videos on this circle theorem, because we want to have a situation whereby all the questions that have come out in WAEC under circle theorem will be dealt with. Kindly subscribe to my channel to get more videos on this circle theory. Thank you so much.
Hey there. Subscribe to my channel. And also press this bell icon.